we're going to sketch the ellipse that's not at the origin. And the first thing I'm going to have to do with this equation that's given is put it into what's called a standard form. And a standard form looks like what's in blue, where it's labeled major axis as vertical. So let me show you how to do that. What I'm going to do is I'm going to group my x terms together. So I'm going to group the 9x squared, the minus 54x, and we're going to complete the square, and I'll show you what that means in just a second. So I'm going to put plus a blank something. I'm going to do the same thing with the y. So I'm going to add 4y squared plus 40y plus another blank something. And then I'm going to set it equal to, instead of 0, I'm going to move this coefficient to this side right here. And the way I can move it to the other side of the equal sign is to subtract it, so I have a negative 37. Because I don't want to focus on that. I only want to focus on the things that actually have a letter right now. So let's start with our x's. What we're going to do first is, for me to complete the square, I need to have a leading coefficient of 1. So I have to factor out a 9. When I factor out a 9 of both terms, I get x squared minus 6x, and I have to figure out something right there. To complete the square, I call this method half and squared. What I'm going to do is I'm going to take half of this term. Half of that term is negative 3. And negative 3 squared is 9. What did I just do? Well, if I was to factor this piece right here, I would have x minus 3 times x minus 3. So that's how I got x minus 3 squared. And I still have this leading coefficient here. Well, to keep an equation balanced, anything that I do to the left side, I have to do the right side. So I didn't just add 9. If I distribute this 9 back in, I get 9x squared. I get minus 54x. So 9 times 9 is 81. So I added 81 to the left side, which means I have to add 81 to the right side. Let's do the same thing with the y's. I'm going to factor out a 4. When I factor out a 4 in both terms, I'm left with a y squared plus 10y plus something. Again, I'm going to complete the square by half and squared. I take half of this term, so half of that term is 5. And 5 squared is 25. So if I factor this piece, I get y plus 5 times y plus 5, which means I have y plus 5, and I have 2 of them. And I still have a leading coefficient. So how much did I add to the y's? Well, if I distribute in, I get 4y squared plus 40y. So 4 times 25 is 100, which means I'm going to add 100. So if I add all of these together, I get negative 37 plus 81 plus 100, which gives me 144. So the next step, because in the general equation, it has to equal 1. So if I want this to equal 1, I'm going to divide everything by 144, and I'm going to simplify. When I take 9 over 144, I get 1/16. So I have x minus 3 squared over 16. Plus, when I simplify 4 and 144, I get y plus 5 squared over 36, and that equals 1. This is the exact form I wanted in, so that now I can sketch my ellipse. I'm going to start by sketching the center. And the center of this ellipse comes from the opposite of the x value, so the opposite of this, which is 3, then the opposite of the y value, which is negative 5. So I'm going to plot 3, negative 5, and this piece right here is the center. The next piece I like to do is I like to underline the largest value on the bottom. And this is going to determine my major axis. And since my major axis, which is the longer one, falls under the y, I'm going to also underline the y value of the center, because that's what I'm going to change to plot my vertices. So in this equation, this is my minor, my major, which is a squared. So this right here is a squared. Well, to find a, I take the square root. So the square root is 6. If this is b squared and that's b squared, then I know b is the square root, which is 4. So to find my vertices, all I'm going to do is I'm going to add and subtract to my long side the value of a. So my vertices are 3, -5 plus 6, which is 3, 1, and 3, -5 minus 6, which is the point 3, -11. So let's plot these. 3, 1 is right here, which means that this length from here to here is the length of a, which is 6. Then if I plot 3, -11, there's my other vertice, and this length from here to here is also a equals 6. So what I have right here is what's called my major axis. The major axis is 2 times a, which equals the major axis. Well, in our case, it's 2 times 6, so the length of the major axis is 12, or you could count from endpoint to endpoint the distance of 12. Now let's plot the minor. The minor is the short one. So in the x direction, because this falls under x, I'm going to go 4 to the left. So that length is b, which is 4. And I'm going to go 4 to the right, and that length is b, which is 4. So 2 times b equals the minor axis, which is the short one. In our case, 2 times 4 equals 8. So the length of the minor axis is a distance of 8. Now all I have to do is make a curve around this, and I have now sketched the ellipse that the center does not fall at the origin.